Hello guys, if you've ever had problem calculating the tension between two forces or more, this video is going to be super useful to you, because in this section we deal with different with a question on tension and on different difficult aspects of physics that many students find super difficult, and it shall be simplified in this video. So at the end of this video you will be able to tackle questions on that. Now this, don't forget that this is Waec Physics 2015 question 11 to 15, and I am Tutor Dami, and we shall be destroying Waec. Now don't forget that if you learn something from this video, click on like button. We have loads of content to send to you that will better help you understand physics. Now let's get to the question now. The question says two strings, each inclined in an angle of 30 degrees to the horizontal, are used to hold the bucket of water weighing 20 Newton. Calculate the tension in each string. Now you have to draw this first. The first thing to do is to draw. Once you draw it, it says two strings, each at 30 degrees. Okay, so you have to draw. Let's begin by drawing this now. Now look at me. It's at 30 degrees to the horizontal, right? Now look at this now. This is the first string, this second string. 30 degrees to the horizontal. Now that means they are 30 degrees. You can see this is my horizontal line, but the strings are at 30 degrees to the horizontal each, right? Now they were used to hold a bucket of water, and the bucket of water weighed down at 20 Newton, right? Now the first thing to do is to calculate the tension in each spring. Now let's find the tension standing upward, the upward tension. Now that means I have to convert this force here, this 30T, into the vertical wing, and this one also to the vertical component. Now when you are changing an angle to vertical component, you must use sine. It will give you a sine function. So that means what I'm saying is that I would first of all say the vertical one that I'm looking for is the upward force. Okay, now remember that upward force equals downward force. That's by the principle of moment. Then we know that the upward force is what? Is the vertical aspect of this force. 30 here, T30. What is the force acting at the vertical side here? It will just be written as T sine 30. Because from this 30 here, the vertical part is opposite over hypotenuse, and that will become sine. Okay, that will become sine 30. So that will become the vertical part is therefore T sine 30. That's T sine 30. That's my vertical force. But it is not only this part that we have double of it also at this side. That will become two of it, one at this side and one at this side. So I have T sine 30 for each times 2, and that is T sine 30 times 2. That is the upward force. Then the downward force is therefore 20 Newton here. 20 Newton. So the total upward force is T sine 30 in two places times 2. That's the upward force. Then the downward force is 20 Newton, and that's what I have here. They are equal. Then to what is now sine 30? Sine 30 is 1/2 or 0.5. So that will become T bracket 1/2 times 2. Then 2 cancels 2, or you can just say 0.5 times 2. It will give you 1, and that will give you 1. 1 times T is T. 1 T is therefore 20 Newton. So my answer is 1 times T, which is T, equals 20 Newton. So the total tension in the spring will give you 20 Newton, and that is your answer. Your answer is simply 20 Newton. Easy peasy, full stop. Let's check number 12 now. A bullet fired vertically upward reaches a height of 500 meters. Neglecting air resistance, calculate the magnitude of the initial velocity of the bullet. Now this is an upward motion question, right? Sorry. This is upward motion question, and you know that if it is motion, all the equation of motions apply. But when the body is going upward, like a bullet is going upward, this is not projectile because there is no angle given. It is not projectile. I know it is a projectile question if an angle is given, but there is no angle given. It's just upward motion. So all the equations of motion are in my mind. Okay, now, but it was far upward. You must know that whenever something is going upward, you must know that the distance is when the height is called distance, or s. On the equation of motion, your s means distance, right? And the one going upward is 500 meters. That means my s, or my height, or my distance is 500 meters. But when something, now I'm told to find the initial velocity, which is u, okay? But when something is going upward, it will get to a final velocity of 0. Like if I throw a stone upward, without someone telling me, I know that my final velocity for upward motion is 0, because the stone will get to a point while going upward and it will stop. That stoppage point is called your final velocity, and that is v. So automatically on your own, you should know that for all upward motion, your v, or your final velocity, is always 0. Then your g, or your acceleration due to gravity, your acceleration is g, and it is negative. Why is it negative? Because it is going upward. That means it is fighting against gravity, and anything against gravity is negative, because it is going against gravity. Now if it is coming downward, it is coming towards gravity. Gravity is very happy because it is coming down. You know, gravity drags it down. So if it is coming down, it is positive. But if it is fighting gravity, it is negative. That means it is against. That means it is against gravity, and that's why it is negative. So therefore, I have S, U, V, G. Now, which equation of motion has all these things? Can you remember? It is simply this: V square equals U square. Oh, I didn't finish writing it down. Oh, I'm so sorry. It is V square equals U square minus 2GS. There should be 2 here. 2GS, or you call it 2AS. But that A has turned to G. It will become minus 2G. And why is it minus? Because it is against gravity. It will become negative. And that's it. Now, remember that my V, my final velocity is 0 because it is against gravity. At the maximum point, it will be 0. So my V is 0. My U is what I'm looking for, my initial velocity. Then my 2 is still 2. My gravity is 10. That's acceleration due to gravity is 10. And you were given here as 10. Okay, so my acceleration due to gravity is 10. Then my distance travel was given to me as 500 meters. So I plug it all in. So I have 0, U is not known, then 2, 10, and 500. That's my distance. Then I'll now make U the subject. That becomes U square equals this one's here, this minus 2GS, they will jump to this side and become plus. And that will become 2GS. And where my 2 is 2, my G is 10, and my S, my distance is 500. You know, 0 square is 0, so it's not relevant. So that will become this one, 2GS, move to this side, and the minus vanish because it has jumped from here to here. The minus disappears automatically. That will become 2. My G is 10, and my distance is 500. Multiply that, you have 2 times 10 times 500 is what? 10,000. Then my U square here, the square here will come here and become square root, right? That will become square root of 10,000, and the answer is just 100 meters. And that is my answer for that upward motion. Don't forget the formula that I use. That for upward motion, your distance is S. Okay? Your U, in this case, my initial velocity was not known. But my V is always 0. And my acceleration due to gravity is always negative. Okay? And that's my answer for that aspect. 100 meters per second. Let's check out number 13 now. A uniform bar AB is balanced on a knife edge, which is 60 centimeters from B by a mass of 22 grams, which hang at C 10 centimeters from A, as illustrated in the diagram above. Calculate the mass of the bar. Now, the mass of the bar is at the middle of the bar. That means I will just draw that. But the mass I'm looking for is at the center. You know, this bar is 100. It is always 100 centimeters. Now, you have all these drawings here, but the mass of the bar, nobody will tell me. I know that the mass of anything is at the center of that thing. And that is the middle of 100 of the bar is 50. Because the total bar is 100. The middle is 50 centimeters. It's at the 50 mark. Okay, now, what is the weight acting down here? So the weight here, I don't know. Therefore, I'll just say moment formula says mass times distance. So I would say the mass here, you know, clockwise movement equals anti-clockwise movement. That means all the movement here equals all the movement at the other side. Now, you know, movement has to do with mass times the distance. Now the mass here is what? 22 grams, right? That's the mass on the left hand side is 22 grams. Then the distance is between 10 to 40. That is the pivotal point. That's the point where the pivot is. The distance is from 10 to 40. That will become 40 minus 10. Mass is 22 and the distance is 40 to 10. That's 40 minus 10 and that will give me 30. Then the second one here, I don't know the mass, so my mass is m. Then the distance is from 50 to 40 and that is 50 minus 40 and that's 10. So it makes 10m. So 10m equals 22 times 30 and that will give me 660 equals 10m. Dividing by this 10. This 10 will move from here to here. So my m or my mass is therefore 660 divided by 10 and that is 66 grams. Easy peasy, and that is the end. My answer for number 13 is therefore 66 grams. Full stop. That is the answer for that question. Number 14 says a body mass 1000 kilograms is released from a height of 10 meters above the ground. Determine its kinetic energy just before it strikes the ground. Now look at this now. You know, kinetic energy formula has to do with 1 over 2mv squared. But is there a mass? Yes. Is there a height? V. Sorry, is there a velocity? In the question, there is no velocity. You are not giving any velocity. So that means I can't use the kinetic formula. I have to change that kinetic energy into potential energy. Do you know that kinetic energy and potential energy can share the same formula? Do you know that in physics? Now, if you don't know that now. If you were asked to find kinetic energy, you can borrow the potential energy formula. And in this case, this question can only be answered by the potential energy formula. So I will say kinetic energy, I won't use its own formula. I will say kinetic energy equals potential energy, which is equal to the potential energy formula, which is mgh. mgh. And therefore, I'll be having it as kinetic energy. Energy kinetic is therefore m. My m is my mass, my g and my h. So kinetic energy is borrowing potential energy formula, right? What's my mass? 1000 kilograms. What's my gravity? 10. And what's my height? 10. In the question, I have it as 10. So just put everything together, you'll be getting 100,000. And that is 10 raised to the power 5. Why 5? It is how many zeros can you see there? 1, 2, 3, 4, and 5. 5 zeros. And that's 10 raised to the power 5 joule. And that is my answer for number 14. Easy peasy. Number 15 says the diagram below illustrated 4 test tubes containing the same volume of a liquid at different pressure. Now these are all test tubes. They have the same amount of liquid, right? But they have different pressure. This one is 2 atmosphere. So yes, that's 2 atmosphere. The B is 1.5 atmosphere. C is 1 atmosphere. And D is half atmosphere. Now, in which of the following of the test tube does the liquid boil last? If they are supplied with the same quantity of heat. Now, if you now eat them, which one will boil last? Now, you should know that as pressure increase, the boiling point increase. So the one with the higher pressure will boil last. The more the pressure, the more the boiling point. That's why the more the pressure, the more the boiling point. That means that all the liquid, they are at different pressure. That means they have been pressurized. That means they have different atmospheric pressure. Okay. Now, the more the atmospheric pressure, the more difficult it is to boil. So that means the one that will boil. So that means the one that will boil last is the one with the highest pressure, and that means the one, the answer A. Why A? Because A has 2 atmosphere. It has the highest pressure. B has 1.5. That's less. C has 1 and D has half. So the one that will boil last is the one with the highest pressure, and that is option A. And that makes the answer A, and the number 15 answer to become A. The only reason why it's boiled is because, remember, the higher the pressure, the higher the boiling point, or the more difficult it is to boil. Just as the higher the impurity, the higher the boiling point, the more difficult the water boils. So what I mean is that if the water is not pure, if you add salt into water, it will be difficult for that water to boil. Just as if you increase the pressure in the water, the more it will be difficult for the water to boil. So the higher the pressure, the higher the boiling point. And that is the answer to number 15. So the one with the highest pressure, number A is correct because it has higher pressure. 2 atmosphere is higher than all the other atmosphere I have here. And that is my answer for number 15. That brings us to the end of this video. Don't forget, if you learn something from this video and you want to get more content from us that will better help you understand physics, click on like button and we'll get across to you with more content that will better help you understand. Until we see you next time, guys, take care of yourself and bye for now.